that pH is less than 7 or acidic, pH is above 7 or basic. All right, let's do some more problem solving. What if the concentration of H plus is not 1 times 10 to the minus something? What if it's 2 times 10 to the minus something? Well, the simple answer, this is my favorite, you just put it in your calculator, okay? Anything, these values you actually don't have to put in your calculator because we just told you that the pH is going to be equal to Y. So it's very simple. No calculator needed there. You can always put it in your calculator if you want to double check yourself. But if you have any other numbers where the base number is not 1, here it's 2. Okay. Anytime the base number is not 1, put it in your calculator. So, for example, what is the pH of a solution that has an H plus concentration that's 2.3 times 10 to the minus 6? What is the pH? All right. So we're going to do the negative. We know pH equals the negative log of 2.3 times 10 to the minus 6, because pH equals the negative log of the concentration of H plus. Okay. So when you put that into your calculator, negative log, and always use parentheses right here. Always use parentheses. If you don't, it might not put your exponent in, the 10 to the negative 6 part. So if you do that, you should get that pH equals 5.64. And you guys double check me on this. You know I can make mistakes just like the best of them. So that's what I got. If I'm wrong, if you get a different answer on these, you know what? I wouldn't be surprised. I bet I will make a mistake somewhere. But that is what I got when I did negative log of 2.3 times 10 to the minus 6. Okay, so simple enough. If you're given an H plus concentration and you're asked what the pH is, very simple. Negative log of that value. Let's do some more problems. What is the pH of a 1 times 10 to the minus 6 molar HCl solution? Is this acidic, basic, or neutral? Okay, well, we are given an acid here, and it's good to know if this is what kind of acid it is, okay? Is it a strong acid? Is it a weak acid? If we were to scroll up all the way back to the table of acid-base strengths showing the strong and the weak acids, we would find that HCl, and you may have already guessed, is a strong acid. What that means is that HCl will completely, one arrow here, remember one arrow, completely disassociates into H plus and Cl minus. All right, so when it's done, we'll have 0 of this left over, and we'll have all products, same concentration of products as the amount of HCl we started out with. So that means the concentration of H plus will be 1 times 10 to the minus 6 molar. Concentration of Cl minus will be 1 times 10 to the minus 6 molar. All right. This is what it means when we have a strong acid. So from writing this out, we have determined our concentration of H plus. And remember, to solve for pH, that's all we need. So we have found out that the concentration of H plus equals 1 times 10 to the minus 6 molar. So remember, pH, that's what we're solving for here, equals the negative log of 1 times 10 to the minus 6. And looky here, our base number is 1, which means our pH is just our exponent. Okay, so pH is going to be equal to 6. You can double check me, put that in your calculator. But if pH equals 6, remember, any pH that is less than 7 is acidic. So this solution is acidic. All right. Okay, number 2. What is the pH of a 4.5 times 10 to the minus 4 molar HCl solution? Here, they're not being so kind. Our base number is not 1, so we're actually going to have to plug this into our calculator and see what we get. But again, this is a strong acid, so HCl will completely dissociate, single arrow. You'll have no reactants left over, you'll have all products. So it'll completely dissociate into H plus and Cl minus. So in the end, we'll have 0 of this, and we'll have all of this, H plus and Cl minus. 4.5. Oh, rats. There we go. 4.5 times 10 to the minus 4 of H plus, and 4.5 times 10 to the minus 4 of Cl minus. That's molar. Okay, so again, because if this was a weak acid, we could not do what we're doing, because we'd have an equilibrium, we'd have to use Ka, we'd have to solve for H plus. But because this is a strong acid, I don't know why I said it like that. Just felt appropriate, you know. Because this is a strong acid, we know it completely dissociates, so we know that the concentration of H plus equals 4.5 times 10 to the minus 4. We know pH equals the negative log of the concentration of H plus. So we just plug this number in right here. So we're going to do the negative log of 4.5 times 10 to the minus 4. Remember, don't forget your negative when you put it into your calculator. When you do this, I got that the pH equals 3.35. Okay, this pH is lower than the one we solved for up here, but that makes sense because we had a lower concentration of HCl. We started out with a smaller amount of HCl, 1 times 10 to the minus 6, compared to 4.5 times 10 to the minus 4. This is more acid down here in this problem. So if we have more acid, we're going to end up with more products, because more acid, more dissociation, or it's going to completely dissociate in both cases, but we end up with more H plus. 4.5 times 10 to the minus 4, again, is greater than 1 times 10 to the minus 6, so it makes sense that this is a lower pH. It's more acidic than the solution in